Hello everybody and welcome back. So in this next lesson, and in fact the next two lessons, we're going to be working through some practical examples that I've put together. Just a few simple setups, things that you would actually use on a daily basis, maybe in a studio or doing your own personal projects. All just applying VEX, applying the same kind of expressions that we've learned, but real world examples that will hopefully make sense and allow you to just practice putting together the code that we've learned. Reading the help file, writing the expressions in the correct way, transferring the data, manipulating and setting the data, all for a practical example. Hopefully this will let you sort of practice creating code and get a little bit more comfortable before we move on to the third week, which is going to be quite advanced stuff. Okay, so at this point, if you're struggling to follow along with these examples, this is the point where I would say go back, learn again, practice a bit. When you can do these smoothly and you can 100% follow and know what this is doing, then I would suggest moving on to the third week. All right, so let's get started. All right, guys, so in this first example, we're just going to be talking about copying attributes across from one geometry to another. So I'm just going to drop down a sphere and change it to polygon mesh so that we've actually got points to use, because with a primitive, it's just one single point. And I'm going to give us quite a lot of geometry here. So I'm going to give 100 rows and columns. Okay, so we have 9,802 points. Okay, and I'm going to duplicate this because we're going to be copying geometry from one to the other, and most often you're going to be copying attributes from one geometry to another when there's the same number of points. Often it will be that you've split one piece of geometry into two different streams, maybe simulated the one and the other remains static, and then you're transferring attributes between the two. So the number of points, the number of primitives, everything is actually the same. Even the point order is the same. That's the most common use of copying attributes across. Okay, sometimes you will want to, maybe your sphere has only 10 rows and 10 columns, but you actually want to get the information from these 82 points across to the first 82 points of this. Maybe, okay, but that's a lot rarer. Normally you're going to need identical geometry to produce a really good result. So in order to have an attribute, I'm just going to drop down a paint node, and I'm just going to paint color. I'm not even going to do a custom attribute. I'm going to literally just paint some color. So let's get funky and creative here. Just do some weird shapes, get some crazy colors, and do some cool things. So you can do this with any attribute, custom attributes, or predefined ones. You can even copy point position, which would be creating a blend shape, which is an example that we are going to do later because it does have a few additional steps. So yeah, there we go. Okay, so I've got a whole bunch of color on this sphere. Okay, and this sphere, the sphere that we're wanting to copy to, has no color. Okay, so we drop down a wrangle. In this case, I'm just doing a normal attribute wrangle set to point. Okay, the reason it's set to point is because our color is a point attribute, right? And then we've already learned this expression, so remember we're going to be wanting to set color on our first input. All right, and remember that our first input is the special one. Our first input is the one that comes out of here, but just having changed. So we're wanting to influence our blank sphere, but we just want to copy the color from this sphere. So we're going to say v at cd. Okay, so because color is a vector, it has red RGB channel, and so it is a vector. And remember, it does know that color is a vector, so you can drop the v, but please do not. Okay, at least cast it the first time you use it in the code, because otherwise you will come across problems in future, especially when you create custom attributes. that are vectors. Maybe you create a v at col to store some color, but without overriding the cd attribute. Then you're going to be in the habit of dropping the v, and then it's going to be disaster. So v at cd equals, so we're setting color, and then we're going to say at up input 1. So that is the first input. So remember, it's 0, then 1. Okay, so it's actually our second input, but it's our input number 1. Underscore, and then the name of the attribute that we're wanting to copy across. Now remember, this is the short form of it. There is a longer form. So let me show you this one first. So if I hit insert on the keyboard, it's going to commit that change. And you'll see that this one has copied the color across from here. Okay. So it matches exactly because there's the exact number of points. Now, instead of doing it this way, the other way, the slightly sort of older way, is, so we're still going to say v at cd, we're going to say equals, and then we're going to use the point expression. Okay, so if I just click on point here and hit F1 on the keyboard, it's actually going to open up a help browser that's pointing to the point expression in Vex. So that's quite a useful way of just checking. You know, if you know that you want to use the point, but you just can't remember the order of the arguments, then you can just hit F1. Okay. Just remember, you have to have the cursor within the text of the actual expression name. If you just randomly hit F1 over here, it will just pop up a normal help browser at the root. Okay. So here we're wanting to point to the geometry. So that's 1. Remember, you can give a full path to the geometry, but if it is plugged into any of our inputs, then we can just use the number, and it's the index number. So 1 is the second one. Okay, comma, and then the attribute name as a string. Okay, see here it's saying string attribute name, so we must put it in quotes. Okay, it can be single quotes or double quotes, either will work. And then the point number that we're wanting to reference. And in this case, the point number on the second input that we want to grab the information from directly matches the point number on this. In other words, point number 0 on our sphere 1 wants to grab the data, the color value from point number 1 on this, point number 0 on this sphere. Point number 10 on here wants to grab from point number 10. So when we use at ptnum, this is the point number of the points that we're busy processing. So in other words, that's the points of the sphere 1. And when it loops over the points, let's say it's on the very first iteration, it's going to be processing point 0. So this value will be 0, and therefore it's going to grab from our first input the color value of point 0 of sphere 2. Okay. So it is possible to use this expression to grab not the corresponding point. Maybe you wanted to actually grab the point number +5, which would mean that point 0 on sphere 1 would have the matching color value of point 5 of sphere 2. Okay, so that may be something that you want to do. Right, so if we fill that in, and you get the exact same result. Okay, so it's up to you which one of these two you use. Like I mentioned before, I used to have a few bugs with this method, this first method, but I'm sure they've ironed that out now. So this is probably a really good way of doing it, is this first one, because it's a lot simpler. But the second one gives us a little bit more flexibility in terms of setting a custom value for which point number we actually reference. So if you need that flexibility, then this is the way to go. That's why I'm showing you both. Okay. And I want to show you guys that it is definitely transferring, and that we're not just displaying this input. And also that this is based on point number and not proximity. So I'm just going to drop down a mountain sop over here and plug it in. So you can see that our first input over here, this sphere, is all noisy. This one is normal. Okay, In fact, I can even transform the one. Let's transform this one along X. We'll just move it aside so there's no overlap. Okay, and then I'll set my template flag so you can see both. All right, and then when we move here, you'll see that it's copying that data perfectly. Right, no matter, even if I change my offset on the mountain, you'll see that the color sticks to those points. And that's because it is being transferred by point number. It has nothing to do with the location of that point and the location of the corresponding point. It is all to do with point number. Okay. Right. So I'm going to switch that off now. And I'm going to show you a little bit more of an advanced example of this, because remember, sometimes we're going to want to copy not based on point number, but actually by ID, whether it's actually the ID attribute or whether we want to create our own custom ID attribute to copy using, right? And if you remember correctly, this expression, this short form, uses this attribute to match under the bindings tab, okay, which by default is set to ID, because most often you're going to want to actually use ID. But I'm going to show you an example where we're not going to use ID for a very good reason. So then we can enter a custom ID attribute, and this will read it correctly. There is also a way to get this type of expression to read ID instead of point number, but we're going to get to that in a later example. Let's just start with this one. Okay. So I'm going to use the same base geometry, but we're just going to put this wrangle off to the side, and I'm going to do something a little different here. So I'm going to drop down a DOP network, okay, and plug it in from my original mountain SOP, okay. And I'm just going to do a quick pop setup. So you need a pop object, you need a pop solver. For anyone who doesn't know, if you're maybe new to Houdini, pop is the particle operation. So we're just doing a basic particle simulation. And most simulations need three things: a solver, an object, and a source. So we're going to now be sourcing. We're scattering on surfaces, and it's asking us which. Do we want to just point to a SOP? I'm going to just take our first context geometry, because what that means is the first input over here. Okay, so you'll see it sourcing all over that and releasing points. You'll see they're all appearing on here but not moving because we don't have any forces. So let me just maybe drop down a pop wind, and I'll just plug it into the same stream over here, and I'm going to set the amplitude of the noise to 1 just so we get some particles coming out. Right, and I'm actually going to increase the birth rate quite a bit over here so we get a massive amount of points coming out so we can see what we're doing. Okay, so that's all we've got there, and I'm going to, outside of here, I'm going to put down a DOP import. It is always better to import, do a DOP import, and with pops you do still get your normal points out, but it's much better practice to always use a DOP import. And here we're going to use one of the expressions that we have learned, which is the op input path, because I don't want to have to point to a DOP network. I mean, I've already got one plugged in. I want to just reference this input. So as a procedural way of doing it, we're just going to, remember, we're going to put a backtick because it's a string. This is a string parameter, okay? And then I'm going to type op input path. In fact, I'm going to just cheat and click on there. And then remember, we're going to put 0 because we want our first input. I mean, there is only one input. And then, oh, sorry. So I'm doing this the wrong way around. We're going to use a string to point to our self. So 1 dot says myself, and 0 says my. So this is my first input. Okay, there we go. So we're going to use that expression, and if I middle click, you'll see that it resolves to this DOP network. Okay, so that's the DOP network that we want to reference. And then I'm just going to go and fetch geometry from the DOP, right? And just make sure that I'm importing geometry as the geometry data path. Okay, so here we correctly have imported our points. And what you'll see is, if by default in a DOP, you're going to get an ID. And this ID is per point that is created. Okay, and even if these points start dying, point numbers will change, because point numbers are an index. There cannot be any gaps. If points 114,193 all the way to 114,224 all died, there cannot be a gap here. So these other points will adjust their point number. But ID, because it is just an attribute stored on the points, will remain exactly the same. So you actually know the original point number of that point, and these IDs will all be unique. Okay, so this is great and very, very useful, right? And this is why you're going to, a lot of the times, want to be copying based on ID instead of point number. However, in this case, we don't want to copy using these IDs because we don't have 395,835 points on this. We just have 9,802. Okay. What we want to do is actually store our original point number, and all these points that are sourced, okay, even when we're sourcing like hundreds of points, thousands of points from one particular location on this geometry, we want it to remember its parent, essentially. So we want it to remember where it came from. If it was born right here at this point, okay, then we want it to remember that point number. Okay, and we want, even when there's 100 points birthed from this particular point, we want all 100 to have the same source ID. Okay, so we're going to drop down a wrangle over here, and we're going to just do a very, very simple attribute create. Look, you can use attribute create if you really want to, but the more I've learned about Vex and you start getting into using it, it's so much easier. I just use wrangles as attribute creates, especially because I can create multiple attributes in like a couple of lines. It's just so much easier. Okay, so we're just going to say so we're setting an integer attribute, okay, because all IDs should be either integers, or sometimes you're going to use strings as IDs, but we'll get around to that. So I at my ID. I'm just gonna call it my ID. You can call it whatever you want, but don't call it ID. The reason for that is because the DOP network is going to be creating ID. There is a way of going into the POP net and sort of stopping it from creating an ID so that it doesn't overwrite your ID, but it's just so much easier to create a custom name so that ID is left to its own devices and you're using a my ID. Okay, but you can call it whatever you want. And we're just going to say equals at ptnum. So because before we've entered the DOP, our point numbers are consistent. There is no time difference, like over time things are not changing or evolving, right? You'll see here this on all these nodes there's a little clock when it is time dependent, which means that frame after frame this node will produce a different result, whereas this here, everything's consistent. Okay, this is not animated, nothing is different. Okay, so because of that, we know our point numbers are consistent. So we're storing a custom attribute from point number, and we're going to do that on our other geometry as well. Okay, so the geometry that we want to copy the color attribute from. All right, let me just move this wrangle off to the side. So now they both have a matching my ID attribute. Okay. Now when we go into this DOP, you'll see that we birth a whole bunch of particles, but these particles have a my ID because they were already on the source, so they inherit all of the source attributes. So you see here we now have my ID, and I'm just going to type in here star ID star so that we filter out and just show the two IDs. Okay, and you'll see how my ID differs from ID. Okay, ID is unique. It will never create another duplicate. It'll never create another ID 0. Okay, even if this one dies and it creates a new particle, that particle will be numbered at the end of this sequence. It will not be numbered at 0. Okay, it will not fill in the gaps. In my ID, there are duplicates. Look how many zeros we have, because these are all particles that have been birthed from very near to that 0 point. Okay, and at the maximum, there's 9,801, which, remember, we've got 9,802 points, but they are numbered from 0 upwards. So the last point in this sequence will have the point number of 9,801. So you see it goes up all the way up to the end, but will not go higher. And that's exactly what we wanted to create, okay? Because it matches this my ID now as well. Because remember, this on here, the my ID is based on point number, which there's 9,801 of them. Okay. And now we can apply the exact same expression to copy. So we are referencing our second input, which is our basic one, but that has the color. And you see it's even offset, so it has nothing to do with proximity. This is not an attribute transfer, but an attribute copy. And we're going to just say here, v at cd, so the exact same thing, equals at op input 1, so we're copying from our second input, which is labeled 1, and the attribute we want to copy is cd, right? And you'll see what has happened. This has not worked. This has not done what we want. Why is that happening? Well, it's because it is finding an ID on here and trying to copy using ID, which means that it's only going to the first 9,802 points are going to find color values, and then the rest are not going to find a corresponding ID on here. So they're just not going to copy anything. Instead, if we come under bindings, we can change this now to my ID. Okay, we feed it a custom value to reference. So then it looks at this point, says, okay, go to the point number on this side that has the matching ID number, okay, from this attribute, and copy its color value, right? And you'll see now, even as these particles simulate, as they move, they are copying values from its source, which is actually an entirely separate piece of geometry over here, okay? So that's pretty cool. Right, so that's it for that example. Now let's move on to the next one. Alright everyone, so here I'm going to show you how to use Vex to basically promote attributes from one class to another on the same piece of geometry. So I've kept our same sphere and our same paint values, but I've cleared up the rest of the scene, and all I'm going to do is drop down an attribute wrangle, sorry. But what we're going to do is promote this from, so we're going to take color, which is a point attribute at the moment, and we're going to promote it to vertices. Okay, so the vertices will store the color information rather than the points themselves. Okay, so in order to do that, I'm going to have to run over the class that I want to promote to. Okay, because we're essentially going to just be getting the attribute value from wherever it is and setting it on the class that we want to run over. So we're going to say run over vertices, okay, and then I'm just going to say v at cd. So I'm setting cd and I'm saying equals to, and now I'll use point, because we cannot use that short form expression, because that's wanting to copy from another input. So here's where we need to use our actual point or vertex or primitive, prim expression, which allows us to basically grab data from a particular class. So even though we're running over vertices, we're going to be grabbing point data. Okay, we're going to grab from point from input 0, because that's where we're wanting to copy from, is our own piece of geometry. Okay, then a string for the attribute name, so I'm going to say cd, and then the point number that we want to grab, right? And we want to just use @ptnum, because the vertices, even though we're running over vertices, they do understand @ptnum. This local variable is the point number that it's busy processing. Now, when it's processing a vertex, each vertex knows which point number it is attached to, okay? And therefore, when you run @ptnum, it is just going to reference that same point, okay? And you'll see when I click away, or if you hit insert, nothing changes. And nothing changes because it has correctly transferred color from a point attribute to a vertex attribute, okay? And because Houdini knows what CD is, and they display CD as color in your viewport, and it can display vertex, point, or primitive colors if there is only one. You'll find some conflict if you have CD at both point and vertex and prim level, then it's just not going to know what to do. But we've correctly promoted it to vertex. It's finding only one CD attribute, so it's displaying it like that. Right. That's just a quick, simple example, but often useful. You won't always, you won't really that often just have a wrangle to promote from one to the other. Often what you're going to do is within your script, you're going to be wanting to reference, let's say you're running over vertices, but you want to reference a point attribute. Then you can do it this way. And instead of storing that data in order to actually promote it, what you may do is store it in just a variable. So you actually leave color as a point attribute, but you reference it within your vertices, do something with that value, and then write out another vertex attribute, for example. Okay. Right, so that's that example, and let's move on to the next one. All right, everyone. So now we're going to be looking at blend shapes. So blend shapes are similar to an attribute copy, like what we did just now, but we're also going to be wanting to blend between them instead of just straight up copying the value exactly as it is. Okay, so we're going to do a linear interpolation, which is a different expression that we'll be using, as well as then I'm going to use this as a way of showing you how to grab IDs in the longer way, which sometimes you need to do depending on how your IDs are set. So let's get into it. So I've got a sphere here, again, 100 points, and rows and columns, and I'm going to copy that as well. Then we're going to throw down a mountain sop, just to create some kind of different shape, right? So we got our squiggly sphere and our normal sphere. Okay, and the normal one is the one that we're wanting to kind of copy these values from. So I'm just going to stick down a wrangle, plug those in, first input, second input. So on our plain normal sphere, I'm wanting to reference our second input. Okay. Now, if we just say v at p equals, and then at op input 1 underscore p, we're going to instantly grab the full values from here. But this is not what we want. We're wanting to do a linear interpolation. So linear interpolation just basically means it's going to figure out where point 1 is on here, on this plane sphere, and where point 1 is on here, and then blend between those 2 points via a straight line. Okay, so it will figure out where it is on here, draws a straight line between the two, and when your linear interpolation value, your bias, is set to 0.5, it will be exactly halfway along that line. Okay, so in other words, the interpolation from one position to the other is linear, both in a straight line and linear in terms of the percentage that it is along that line. Okay, so we're going to use LERP, lerp. Okay, you'll often hear this expression, people referring to lerp, which it sounds kind of funny. This is what they're referring to. It's a linear interpolation. You also get slurp, which is spherical linear interpolation, which is used for linearly interpolating between quaternion values. So maybe we'll actually look at that sometime later. But this is what you're going to basically use as the equivalent of if I drop down a point VOP. I want to show you this because I did mention before that some of the expressions are different to the corresponding nodes in a VOP. For example, you do get a point import point attribute, which is kind of like your point expression. So that's quite similar, but in here it's mix. Okay, so the mix node is actually running the lerp function, which is so completely different, right? So it can be a little bit confusing when moving from VOPs to VEX, so just keep stuff like this in mind. Okay, so I'm going to click on the lerp and hit F1 so that we can see what this is doing. So let me try that again. Okay, it seems to just not pop up, but anyway, here it is. Right, so lerp vex function, okay, so performs bilinear interpolation between the values, okay. So we feed it, okay, different types. You can have float, or you can linear interpolate between different vectors, or even BSDFs, okay. In this case, we're using a vector, right? So we're feeding it one point value, so one vector, which is our current point number, sorry, not point number, point position. And then our second value is the point position on the second input, okay. Now this op input expression is grabbing the point values from here. How do we grab our current point positions? Is just v at p. So that's why our two first arguments is our current point position and our point position on our second input, okay. And then the amount over here is simply the the value, the bias. So if we have 0.5, the returned point position value will be halfway between this point position and this point position, okay. And in order to make this a nice slider, I'm going to type CHF, okay, because I want a single slider. You'll see here you can have, there's two different vector ones, one where you have a float, which is just blending between all the x, y, and z coordinates equally, whereas here you have a different blend for x, y, and z, okay. So we're just going to do CHF, and then I'm just going to call it blend. Okay, so I'm going to close that expression, and then I'm going to close the lerp expression, and then end with a semicolon. Okay, I'm going to hit insert. You'll see nothing happens because this value is 0 at the moment, and we don't have our slider because I haven't clicked here. So if you click this create spare parameters, it's then going to create our slider, which is at 0. So 0 is basically saying blend between this position and this position, but biased all the way to this. So it's going to do nothing. But as I slide this up, you'll see it blends into it. When this is set to 1, it will match exactly to our mountain SOP. But we can now set it to something like 0.5, and it will be exactly halfway between our mountain and our sphere. Okay, so this is how we do just straight, blend shapes, linear blend shapes, okay. And in this case, this is based on point number, okay, because these have matching point numbers, which most blend shapes are going to use matching point numbers. I mean, any blend shapes in an actual rig will be the same character, same face, same geometry, point number, point count, all of that is exactly the same. So this is the most common way of doing just a standard blend shape. But sometimes you're going to have something that gives you, let's say, like the same point count but different point order, okay, and that can cause your blend shapes to break. So we're going to fix that using an ID, okay. So we're going to do a similar example. In fact, I'm just going to copy this, and so not to get confused, we'll just move over here. So we have our same sphere, and we have our mountain sphere, but let's say we use I'm just going to use a sort node to randomly sort the point numbers, okay. I'm going to take point sort and just say random, okay. And you can change this. So you see here, if I change to show point numbers, you'll see here they are changing as I change the seed. Okay. So now even though these have the same number of points, they actually do not match. And if I use the same interpolation, so I'm just going to plug these two in here, you'll see that this is going to be completely broken. Okay. When it's there, it will be perfect, and then it just messes up completely. Because each point is then going to its corresponding point number, but its point number is not anywhere near where it should be. Okay. So in order to fix this, we're going to use an ID. Okay. So similar to what we did in the attribute copy section, we're just going to say I at ID equals at ptnum. Okay. And I can copy this same expression to here before the sort. Now I just want to clarify the sort. I'm using this node to randomly sort point numbers to mimic what may happen. We've had examples of, for example, a model gets changed, but it doesn't have different point count. It's the same thing, but they maybe change the order of the props that were embedded within the one Alembic file. So now it actually still the same number of points, but they are different order, different point count. I'm sorry, same point count, different point numbers. Okay, so sometimes you'll have a simulation, and then you'll rerun that simulation with a different ID, or something will cause the numbers to change. So you wouldn't really ever just sort randomly and then have to fix it. Okay, this over here is simply mimicking something that could happen, which causes the numbers to be different. Okay, so if you are able to go back to the original even before that thing is happening, even because it may be operations that are necessary, you may have to run it through a simulation, and for some reason the point numbers are changed. Okay, then before you enter your simulation, if you can store an ID, then you can store an ID on your source geometry as well, and then interpolate between those two. Okay, and the reason this is working straight away without any additional work is because we're using this up input expression, because remember the binding is set to automatically look at ID. If we had used a different attribute, so maybe my ID, like we did in the previous example, then we would just have to change this to my ID, and then it would work. Now I'm going to take this moment to show you the longer way of doing this if you need to. For example, if you find, like I did at one stage, that this bugs out and doesn't work, then you know how to do it. Or, like I said, sometimes there's a need to do it the long way, because you actually need to write custom expressions in terms of like which ID matches which ID on, from the source to the reference geometry. Okay, so let's write that. I'm going to put 2 slashes to comment this out, and we're just going to write the longer form of this. So I'm going to say v at p equals, and I'm still doing the same function. I'm still doing a lerp between v at p, but we're going to use a different expression to figure out the corresponding point position on this second geometry. Okay, and the function that we're going to use is, so I'm going to use a point. I'm referencing my second input, which is I am index 1. Then I'm referencing my attribute name. In fact, I'm going to hit F1 on this and show you the point. I'm going to pull up the arguments here just so you can see what I'm doing. So I'm filling in the geometry. I'm giving it the attribute name, which is a string. And then I'm giving it the point number. Now, which point number do we tell it to search for? We can't just put at ptnum, because the whole point is the point numbers on here do not correspond to what is on the second input. So we need to match by ID in order to find the corresponding point number. And in order to do that, we're going to use a function called find attribval. Okay, because that's exactly what we're doing. We're looking on this geometry to find a matching attribute value. Okay, so let me hover over this and hit F1. So now we can see the arguments for this. Okay, see, finds a primitive or point or vertex that has a certain attribute value. right? And we know what value we're looking for. We're looking for the ID, because they have matching IDs. So we're saying go and find which point has the matching ID, and then give me that point number, because we need to feed point number into the lerp, we need to feed point number into the point expression, which is going to fetch the point position value, and that point position value needs to be fed into the lerp. Okay, so it's a bit complex here, but I hope you guys are following. So we're going to find attribute value. We're looking at, so which geometry? So again, we're looking at 1. Okay. Then it's going to ask us an attribute class, and it's a string. If you're not sure what this is, remember that you can come and read here in the help file. This is why I had that whole lesson on showing you how to use the help file, because I think you guys really should use it, rely on it. Okay. Even people in the studio, professionals that are using Vex every day, are using this help file. Okay. So do it. So you think here it says you need to give one of detail, or global, point, prim, or vertex in quotes. So you see it's asking for a string, and it just wants to know which class it should look for that attribute on. And our ID is on point level, so we're just going to put quotes and point. And you see I put the single quotes here. That's just a habit from coding in Python, but you can put these double quotes as well. Either one will work. So 1, then point, then our third argument is the attribute name. Okay, so what attributes are we looking for? Well, it is ID, and also it's a string. Okay, so now we need to feed it the value, and it is an integer or a string, depending on whatever attribute we fed it. Okay, and the attribute value of the ID that we're looking for, we can grab using i@id, because when we run this, when you say i@id, it's grabbing the ID values of the current point that it's busy processing, which means on the first geometry. In other words, whatever's plugged into this first one, it's looking at its ID value. Okay, so for example, on point 0, it's going to look for 0, but it's looking for 0 on the ID attribute, which is a point class on the on the second input, which is index 0. Okay, so all we're telling it is go and look for ID 0 on this side. Okay, and that's our last argument. There is a fifth, 1, 2, 3, 4, 5. Yeah, there is a fifth argument over here, which, but it has a default. So remember I told you we do not need to fill this in, and it will default to 0 unless we fill something in. So this is if it finds multiple elements, then it will be essentially returning a whole array of values. So we need to tell it which one, and 0 means the first one. In this case, we don't have any duplicates, we don't have any multiple values, so which at 0 is perfect. But if you do happen to be searching for something that has multiple matching values, then here you can actually put this inside of a loop and loop through. So you'd say which 0, which 1, which 2, and you'd store all those values and then do whatever you want with them. Grab the highest one or average them or whatever it is that you're wanting to do. Okay. So we're going to leave that argument out because it has a default, so we do not need to fill it in. Right? We're going to close this expression, so that's the end of the find attrib val. And you'll see, by the way, I haven't pointed this out yet, but the bracket has this little dotted green box around it when I'm next to the bracket on the other side. Okay, this is just a visual way of seeing that I've closed every expression. Okay, because remember, with coding, writing it perfectly is so vital. You have to write it perfectly. I heard a really good analogy of coding as it's like writing a book, except that if you miss one comma, then nobody knows who the murderer was. And that's exactly what it's like. Literally, if you put one comma in the wrong place or one thing, the whole script breaks. Okay, doesn't just do most of it and then kind of stumble, but everything breaks. Okay, so this is helping you know that you've closed this expression. Now we have a point expression which is open here, but we need to close it as well. Okay, now with point, did we give it all the arguments we needed to? Let's go back and double check. Remember, we need to give it geometry, which we did, attribute name, which we did, and then point number, which we did using another expression. So yes, we've given it all the arguments, and now I can close it. When I close it, you'll see that it is highlighting this to show that they correspond. Okay, and then we are finishing our lerp function. Now if I hit F1 on lerp, remember we need to give it 3 values. We've given it our first point position, and then our second point position. See, instead of that, we've given it this long form expression. We still need to give it our blend value. So I'm just going to copy and paste that in, and then close this expression. When I close that, you'll see it highlights on that side, and then we can put a semicolon. Okay, I'm just showing you that now like in so much detail, because when you start typing, you have multiple expressions within expressions within expressions. It becomes very complex, and keeping track of the number of closed brackets can be crazy. Sometimes you have this massive expression where at the end you have like that many closed brackets, and actually you then start thinking, oh, how many do I need? And you have to go back and count. Well, anyway, this helps you. Okay, so let's hit insert and have a look at whether this has worked. And there we go. Works perfectly. So it does exactly the same thing as this does. And yes, obviously, if both work, then why not just do the short one? But sometimes you'll need to find a matching attribute value in a different class, or a different, that the ID on the left matches something called my ID on the right. Then you can fill in my ID here, but then I at ID. So then you can do different attributes that do match. Or you could search for ID +1. Or if you're finding multiple matching IDs, then you use that which inside of a loop. Now those are all things that you cannot do with this function. So short forms are great when you only need them to do the basic. When you need to do more complicated things, you need to learn these. So please do not be lazy about learning the right way, the long way to do it, even if you don't use it that often. Just practicing it once or twice will put it in your memory, and then at least you'll know what can be done. Now, I'm going to show you one more version of this very quickly, okay? And it is very similar, so in fact I'm even going to copy this whole thing. Except instead of doing this longer find attrib val, there is a slightly shorter version. So we're still using point here, so we still have the flexibility of, adding additional functionality that this one does not have. But there is a slightly shorter version of this find attrib val. So just for interest's sake, I'm going to show you. It's called ID to point. Okay. Because they knew that people are going to be using this find attrib val all the time to be matching IDs. So they kind of created a quicker, shorter version of this, which is just say ID to point, and well, let's pop up the. So let me hit F1, and we'll pop up the help file, and it says here ID to point. We need to give it a geometry and an ID. That's it. Okay, so we just feed it 1 because we're looking at our second input, and we feed it I at ID. Okay, so we feed it our current matching ID point, like ID value, and this will work exactly the same. Okay, but again, this then is assuming that the matching ID has the same class on this side, same ID name, everything. Okay, whereas this expression allows us to do some more complex things. So there's a variety of complexity and simplicity that you should use depending on what you're trying to do. Okay. Right, everyone. So hopefully that makes sense, and you're understanding Vex a little bit more and how to write the code and get the results that you want. So we're going to finish it there for this week, and then next week we're going to continue with more practical examples, and then after that hopefully you'll understand the basics of Vex. So thank you very much for listening, and see you guys in the next lesson.